Hi everyone, and welcome to part 3 of the Absio Python 3 demo. In this portion, we'll be talking about the Absio ecosystem as a whole and how we have high-level utilities such as users, providers, and the Absio secured container. By utilizing these things, it becomes trivial to share data. We can begin by importing the Absio library and initializing it with an API key. If you are in need of one, you can contact sales@absio.com for a legit key. This one is only good for this demo. Now, we're going to go ahead and create 2 users. By default, this uses the server cached OFS provider, which means that we've created these users on the Absio broker application, as well as cached the results locally in the Absio obfuscating file system, or the OFS. So each user needs to have a password, a passphrase, and a reminder, and we will create 2 of them that we will call Alice and Bob. So we call absio.user.create, provide that password, reminder, and passphrase, and we can see that this one takes a little bit of time as it goes out to the server and creates the users, and then comes back and stores the results in the Absio obfuscating file system. So we can see that after having printed these users, we have the first one, which is C2B, or Alice, and 1AF27, which is Bob. Now, while we have used UUIDs automatically for each user, you could map these to known identities within your existing system. And similarly, because we've given human names to these users, it doesn't mean that they actually have to be humans, but it's just an identity, can refer to anything at all. It could be an actual human, it could be an application that you have running, a system, a device, it doesn't really matter, it's just an identity. But let's go ahead and log in as Alice. So to do that, we call absio.login with her ID, as well as providing the password associated with her account. And when we do that, we return back the user who's been logged in. So that's getting started with the users and kind of the providers at the same point, although it was just implicitly done for us. So now we can jump into the Absio secured container. And this is the fundamental encrypted data structure that exists in the Absio ecosystem. It's comprised of 2 main parts, a header and a content. Now, the header is any information about the content that's private or sensitive that needs to be encrypted, and it needs to remain with the data wherever it goes. The restriction is that the header must be JSON serializable, but the nice thing is that it can be independently decrypted without downloading or decrypting the entire content of the message. So the content of the message is basically the data payload. There's no limitations here as to the size or format of the data. Just shove in raw bytes and get raw bytes back out. So under the hood, when we create these Absio secured containers, we're using all of the previously mentioned technology. For each container, there's going to be a unique set of AES 256 and HMAC keys, and those keys are going to be uniquely encrypted and then shared with each recipient using the Absio integrated encryption scheme. So by taking those keys as required to validate the content of the container as well as do the decryption of it, and then sharing it uniquely, that allows very easy revocation or addition of recipients without needing to encrypt or re-encrypt the original actual content object. The header and content are both separately encrypted using that AES 256 key. And now under the hood, it will again use ECDSA as well as HMAC to validate the integrity and the authenticity of the message. So let's put that into practice now, and let's see how Alice can create a shared container and share it with Bob. She can call absio.container.create and provide in a header. So because it needs to be JSON serializable, we're just going to populate this with a dictionary of a simple text string for the key that says read only is true. Your application could then enforce this such that Bob is not able to print or do whatever with the message, can't forward it on. He can only view it. The content of the message is, in our case, just a byte string that says, Bob, this message is for your eyes only. And here we can specify with whom this container will be shared with. And we'll see in just a few minutes about the specifics of this access list. But for right now, it's getting shared with both Bob and Alice herself. Now, this final keyword argument here of type is not encrypted or otherwise protected and allows you to organize your various content types. It is a searchable metadata string. So once we've created this container, we're going to print it out. We're going to also look at the header and content portions as well as that final type. We can see that the container was created, and by default during the creation process it is encrypted. When we look at the header portion of the payload, we can see that it is a JSON payload and its encrypted data is this random gibberish. And the content portion is here. It's just a raw payload and it is also encrypted with some gibberish. Finally, we can see that the container type, where we specified here as being email, is not encrypted. And again, that's just something that's metadata that makes it easier for you to organize without needing to decrypt any portion of the payload. Now, when we had specified the access list here of both Bob and Alice, we can look at the container access as it's given, and we can see that it is a dictionary where the key is the user and the value is the specific access associated with that user. So in this case, we can see that 1AF27, which is Bob, has limited amount of access. Bob has permissions to download the container, decrypt the container, view the access events associated with the container, and view the access itself. That's all Bob's able to do. Now the other user, Alice, on the other hand, Alice has full permissions. She can download the container, decrypt it, upload a new version, view the access lengths, also view the type of the container, modify the type of the container, view the access, as well as modify the access. So Alice could remove Bob as a valid recipient and add in Charlie, for instance, if we had a user Charlie. So that is how access can be fine-tuned. We can also see that there is an expiration associated with the access. So if we desired, we could set Bob's access to expire, let's say 5 minutes after he was sent the content. Now, we're also going to see how each user has a unique, what we call key blob, and that's the shared information required for them to derive that AES-256 and HMAC digest key. So let's look at Alice's key blob, and let's look at Bob's key blob. Both of these look like random gibberish. They don't look the same, but let's just validate by assertion that those two things are not equal. And by running that command, we can assert that Alice's key blob is unique. It does not match Bob's key blob. So now from Bob's perspective, let's go ahead and log in and retrieve that shared container. So we're going to call absio.login. We'll provide Bob's ID as well as his password. And we will call absio.container.get with the ID of the container to retrieve. And once we've done that, we will print out the various bits. And we can see that by default, when we grab the container, we go ahead and decrypt it, so it is no longer encrypted. And then the header is available. We can see that it's plain text data, and it contains our dictionary that we had created during construction of this container, that it is read-only, and that the raw payload for the content matches our original message, specifically for Bob. So Bob is able to use his unique key blob to first verify the HMAC digest, and then recreate the AES-256 symmetric decryption key and do this decryption. So that is how easy Absio makes it to create users and share content uniquely between them. Thank you very much.